Hello, grade 8. How are you all? This is Mr. Mahdi. If there is any new student, this lecture for week 4. This is the third lecture for us together. Last two lectures was about triangles, angles, and parallel lines, and the first lecture was about solving equations. But I saw some gaps in algebra, so I decided to explain or re-explain the lesson again from grade 7 in details, okay, and from the beginning. So I saw many gaps in algebraic expressions. So let's start here. The first or this lecture would be divided into two parts. The first part is here. The objectives of the first part are to define algebraic expressions, identify monomial, term, coefficient, variable, unknown, collect like terms, similar monomials, identify lateral writing of monomials. Okay, this is the first part. So let's start directly here. What do you mean by numerical expression? It's a mathematical sentence containing numbers and operations like plus, minus, divide, and times. Okay? Algebraic expression is a mathematical sentence containing number operations, same number operations, but added to it letters A, B, C, X, Y, and those are called the variables or the unknowns, but usually we use this, which is a variable. Okay? Example 7 minus x plus 2y minus 3. X is a variable, y is a variable, 7 and 3 are numbers, and so on. Okay, so term monomial in an algebraic expression. In any algebraic expression, there are terms or monomials. Okay, each monomial has a sign, either positive or negative, a coefficient, a number, and a variable. Okay, variables. The variable has an exponent. What do you mean by exponent? The power. Let's see how. Example. Look at this example. 3y minus 2x squared y cubed plus 5xy squared plus xy minus 2. All this is called an algebraic expression. Okay. The signs here are positive, negative, positive, negative, negative. Okay. It contains many terms. Okay. Each one of those is called a term. This is a term, and this is a term, this is a term, term. Each term contains many or different components than the other. How? Let's see how. For example, 3y, its sign is positive. Let me start by 3y. This. Its sign is positive, and the coefficient is 3. The number that's multiplied by the variable is called the coefficient. Variable is y, and exponent 1. What do you mean by exponent 1? Right. Let me just explain or re-explain here a little bit aside. If you have x or y with nothing, this is called exponent 1. The exponent could be here above. For example, x power 2, the exponent is 2. X power 3, the exponent is 3. The exponent is the power that's above from the right side of the variable. X power 4, the exponent is 4. X, the exponent is 1. But usually we never write 1. We don't write 1. So just write X or Y or Z or T or A. All of those variables has an exponent. Each one has an exponent 1, 1, 1. But we usually never don't write 1. Okay? We usually just write it without 1. So anyway, let's look at this term, which is negative 2x squared y cubed. Look, x squared y cubed. So negative 2x squared y cubed. Its sign is negative, its coefficient is 2, and its variable x, is x with exponent 2, and the other variable is y with exponent 3. So just write like that. Okay. Let's go to the second or to the next one. 5xy squared. So its sign is positive. its coefficient is 5, its variable is x with exponent 1, and it's y with exponent 2. It's not very hard, it's just very easy. Okay, plus xy, the sign is positive. This one, let me change the color by blue. This sign is positive, coefficient 1, variable x with exponent 1, variable y with exponent 1. Okay, and minus 2, it's just a number. Done? Okay, so let's go to the next one. Like terms, or like monomials, or similar terms, or similar monomials. It's the same monomial. How? يعني the same. It's the same variable with the same exponent. Let's see how. Two terms or two monomials are like or similar if they have same variable, okay, and the variable have the same exponent. So same variable with same exponent. How? 3x and minus 7x. We never look at the coefficients. We just look at the variable with its exponent. So x with exponent 1, x with exponent 1. Those are called like terms. Okay? 4x squared and 3x squared. We have x squared and x squared. Okay? So those are having the same variable. Okay? Like here. Let me just color the only the variables just to observe. Here we have x squared and here we have x squared. Look at those two terms first. Minus x squared yz cubed 2x squared yz cubed. Compare x and x, they have the same exponent. Y and y have the same exponent. Z and z, z cubed and z cubed, they have the same exponent. So they are like terms. Okay, next one, x cubed with x power 5. So they are not like terms. They are not like terms. Okay, here is x cubed and here is x power 5. 5x cubed, y power 4 z squared, 7. X cubed, we have the same x cubed. Okay, y power 4, we have y cube here. So look, they are different. So they are not like terms. See how? They are not like terms. Z square, yes, it's the same. But to have like terms, they must all be the same. All the variables, they must be the same. Okay? Same variable and same exponent. I mean y power 4, y cube. 4 and 3 are different. Anyway, let's go to the next one. Lateral writing of terms or monomials. It's a simplified way to write any monomial. Example, 2 times x. Here we should differentiate between the times sign, okay, and the x sign, okay. So in order to differentiate between them, in your copybooks you must write like this. For example, 2 times, never write x like this. So the teacher couldn't differentiate between this and this. Which one is x, which one is times? So in order to differentiate between them, okay, you must write the times sign like this, okay, and times sign like this, sorry, times, and the x like that, okay, or like this, or like that, okay. So just keep this part and keep it just rounded like this or curved in that way. Never write x like that, okay. This is times and this is x, so you should differentiate. Now look at this here, times x. So 2 times x equal to x. Here also we should write it like this. Good. This x. Just if I change the font, it should be like this one. It's okay, no problem here. But in your copybook, you must write it that way. Okay? So look at this also. 3 times a times b squared. Okay, so it will be 3ab squared. Just y times y times y is y cubed. A plus a is equal to a. Okay, these are called the like terms. A plus a like terms. Here we are adding. Okay, but anyway, uh, if you multiply, you should stick all together. Y times y times y. Never write y. You should write y cubed. Y, since the exponent of y here is 1, and here it's 1, and here it's 1, so we add, so it will be 1 plus 1 plus 1 is 3. So a plus a equal 2a here. Y, since a plus a, not times a. If it was a times a, like this, it should be written a squared. So this is the difference we multiply and divide. Since in the last lecture I saw some gaps in this, okay, some gaps with some students. Anyway, so a times a is a squared, but a plus a is 2a. Okay, you could write it as a note here, x times x. You could write also the times like small letters, small, very small, but just like times. Okay, x times x equal x squared, but x plus x equal 2x. Okay, a very good example to remember that x plus x is 2x, or how to add. Suppose that I told you, or this expression, apple plus apple. So the answer will be apple square. Of course, no. It should be 2 apples. Okay, and you'll consider here that each x is an apple. Okay, each variable is an apple. Okay, so 2 apples, 2x. Here, let's go to the next slide. That in here, this slide, just I want you to solve it with me. Monomial here in this slide, this question I need to complete here. Okay, I need to complete. So this are the given. Those are the given, and in red spaces that we need to complete. So anyway, the first one is minus 6x power 7. Okay, so look at this. What's the variable here? It's x. What's the coefficient? The coefficient is minus 6. Okay, what's the exponent? The exponent is 7. Okay, minus 3.54 t power 4 type. For example, look at this. The variable is t, and the coefficient is minus 3.54, and the exponent of the variable is 4. So, if you wanted to write it without looking at the answer, what should you write here? The variable is t, the coefficient is minus 3.54, and the variable is t. So, what's the exponent for? So, you should write it like this. See here, it's the same. 5a power 3. 5a power 3. The exponent here is 3, and the variable is a, and the coefficient is 5. So the variable is a, the coefficient is 5, and the exponent is 3. Variable z, coefficient 6, and the exponent 2. So it's 6z squared. The coefficient is 6, so we write 6 variable z squared. Okay, fine. Collect the like terms in that question. So here, he wants you to collect the like terms. Look at the first one. Look at the first one, which is 4y power 6. So you will search here for another one like 4y power 6, a like term. So in order to find a like term, it should be y power 6 with any coefficient. So is there any y power 6 here? No. So just ignore. Okay. Look at the second one. 2x cubed. Is there any other 2x cubed here? Or any other x cubed? Any other monomial with x cubed? Yes, it's 0.3x cubed. So we said here that the coefficient doesn't matter. I need only the variable and the power. They are the same. Look at the third one. Minus 4a squared b power 5. Look at this. 6a squared b power 5. So it's the same. Minus 1.5 a squared b power 5. Also it's the same. 3.5 a squared b power 5. All those are like terms. Okay? So we still have this 2cz a squared b squared. Look at the variables here. Z a squared b squared c. C is here. B squared, a squared, and z. Okay? But what's the difference here? Yeah, there is no difference. Why? Since you are multiplying them. Since you are multiplying all those together, so it's okay if you write c at the beginning or at the end. It's the same. Yani another example for this one is, for example, 2xy squared and 3y squared x. Those are like terms, same variables, whatever the location of the variable in the beginning, at the end, since they are multiplied. Okay, so they are like terms. Those terms. Get the idea here? So 6a, sorry, here 2c z a squared b squared minus 5.6. We said we ignore this. Z is here, a squared is here, b squared is here, and c is here. So they are like that. Okay, so this like that. That's it. I hope you understood the idea very well. Okay, but let me go to the next one. Match each writing to its corresponding expression. These are not just exercises; they are solved exercises for you. Okay, in the worksheet you will you'll have the same exercises as this, but you'll solve them alone. Okay, so let's check here. 1x is which one of this? 0.5x, 2x, 0x minus x is x. Okay, so 1x is x. 0x, so 0 times x is 0, whatever x is. Why? Since 0 times any number is 0. Okay? Any number other than 0. 0 times 1, 0 times 2, 0 times 3, 0 times 5. Okay, any number 0 times it, the answer should be 0. But 0 times 0, just ignore this level. Okay? Okay. So minus 1 times x. Minus 1 times x is minus x. Okay? Half x, half is 0.5. So it is 0.5x. See here? That's it. And the last one, which is x plus x. X plus x is 2x. Okay? That's it. So let's go to the next one. We need more colors here since there are a lot. X plus y. Here you need to match each expression with the word. With the word sentence. And with the sentence that represents it. For example, x plus y, it is the third of a number, quadruple of a number, the sum of two numbers, quarter of a number, double of a number, triple, half number, reciprocal of a number, opposite of a number. So x plus y, x is a number and y is a number, and the plus, so it's the sum. You are adding them, so it's the sum of two numbers. Okay, go to the next one. X over 2. X over 2 is a third of a number, quadruple, quarter, double, triple, half. X over 2. X over 2, it means that you are dividing x by 2. So it's half of a number. Okay? Yeah. Go to the next. X plus x. It's the same as this. So it is sum of two numbers. So it's the same as this also. So I just color it like this. Okay, it's green and blue. X plus x, sum of two numbers. Okay, so let me start here designing some shapes. X over 4. Huh? X over 4. It is a third of a number? No, it's a quadruple of a number. Quadruple of a number, or a quarter of a number, or double of a number. So look at this, quarter over 4, it is a quarter of a number. So it's for this. Okay, it's quarter. Let's go to another one. 4x. 4x is third of a number, quadruple of a number, a double of a number, triple of a number. Triple yani times 3, double yani times 2. So quadruple yani, which means times 4. So this one. Okay, should just memorize this. Let's check now 2x. 2x. Okay, 2x. So 2x is for what? Third of a number, double of a number. Yes, it is a double of a number. Okay, it's a double of a number. Again, let's go to x over 3. Sorry. 2x. 2x is for a double of a number. Okay, but x over 3. X over 3. Let me change the color here. X over 3. It is a third of a number. It's a triple of a number. No, it is a third of a number. It's not triple. Triple should be 3x. Okay? Yes, that's it. 3x. So 3x is for this. So 3x is for this one. Okay? So 3x is for triple of a number. Done? There's a remark, I'll say it at the end here. Again, negative y, it's for the opposite of a number. So negative y is for the opposite of a number. Okay, negative y, the opposite of positive y is negative y. And finally, 1 over x is for reciprocal of a number. Okay, 1 over x is called the reciprocal of a number. Here, if you got it here, when I was talking about x plus x, it is the sum of two numbers. Yes, but it's something else also. X plus x is 2x. So 2x, you should go also to a double of a number. Okay, so a double of a number. So it's also the green one. Anyway, they are matched here. If you get confused with the colors, they are matched. Okay, and solved. So you could revise them again. Done? Let's do more examples. Understand it more. So, write literally in a simplified way. 3 times x is 3x. Minus half times a squared times b, it's minus half a squared b. What do we mean here? We remove the multiply sign. We remove the times sign here. Okay, we remove it and just we stick all the variables and the coefficients together. Okay, 4 times x times y times z, so it's 4xyz. Simple. Minus x times x squared y cubed, it's minus x squared y cubed. 1 times a times b times c, it's abc. Y times y times y, it's y cubed, as I told you before. X cubed times x squared times x. So when I'm multiplying with the same base, we add the powers. Of course, you took this before. So we add the powers. So the power is 3, and the power here is 2, and the power of x, or the exponent I mean, it's 1. So 3 plus 2 plus 1, it is 6. So x power 6. Okay? 0 times a times b times anything, you'll get 0. Also, we talked about 0. Give two like or similar monomials. For example, This is the question in the black, which is 4xy. So give any other two like similar monomials. 2xy minus 3xy. You can give else. You can give 4xy, sorry, 7xy, 11xy. Never look at the coefficient, just look at the variables. Minus 5a squared b squared. So you could give 7a squared b squared minus 10a squared b squared. Anything else? Half abc. So give me any other similar or like term. 1 over 4 abc, 3 abc, 10 abc, 100 abc, whatever. Okay. You should have abc, whatever the coefficient. Collect the like terms here. Look at this, all this. Okay. So what is the like? What are the like terms? Let's collect them. 5x squared y squared z. So let's color all the like terms to this. X squared y, no. X cubed z, no. X squared y, this, that, that. X squared y squared z, yes. Else, no. Look at the green one. Minus 3x squared y. This, no. This, yes. 6x squared y. This, no. I'm supposing you are saying no. This, also no. This, no. That, no. Here, 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 here. They are different. So just those. Okay, let's check the third one. Let me color it by yellow. Minus x cubed z. Okay, negative x cubed z. Minus 9y cubed, no. X cubed z, yes, we have x cubed z. But here we have negative 4. Okay, what's the problem? Negative 4, it's okay. I need only coefficients. Okay, no x cubed z. X cubed z here. No, it's not. X cubed z. Oh, here xz cubed, so it's not. And here it's not. Oh, just wait. X cubed z. Yes, it is. Okay. The next one. Minus 9y cubed. So 11y cubed is the same. This is not. And this is yes. Okay. Let's check the weight here. We still have x cubed z. Look, I didn't see it. Why? Because the circle came here. So let me remove the circle, or let me just take it here, right? Yeah, now it's clear. Now I saw it. Sorry. So this is x cubed z. That's it. Okay, so we have 4x cubed z here with negative coefficients, with different coefficients. Minus 5xy squared z, there is nothing. Minus 5xz cubed, there is nothing. So we never color this y, since they are not like terms, any of them. Okay, I hope it's clear. So let's go to the next part, which is part 2. You could take a break. Okay, solve parts of the worksheet that's related to this section. There's a question about like terms. Try to solve the questions that are related here, and then you may go to the part 2. Okay, so in part 2, objectives: find the numerical value of an algebraic expression, multiply two terms, reduce like terms, reduce algebraic expression, perform operations. Okay, so let's go. The numerical value of an algebraic expression. To find the numerical value of an algebraic expression, replace the variable or variables in the algebraic expression by the given value of the variable or the variables. Okay, example: 7 plus x for x equal 3. What do you mean here? The expression is 7 plus x. Okay, for x equal 3, so it means to replace x by 3. Okay, so you need to replace x by 3. This x, you need to replace it by 3. So the answer will be instead of 7 plus x, it should be 7 plus 3. And we made here like this. It was 7 plus x, but we replaced this x by 3. So we removed x and we wrote 3. So it will be 7 plus 3, so it's equal 10. So this is the numerical expression. Okay, numerical value. And you are here finding the value. Okay, another example. 7 minus y. This is an expression. Okay, this is an expression. 7 minus y. For y equal negative 2. So what does this mean? What you need to do here is to replace y by negative 2. Okay, is to replace y by negative 2. So it will be 10 minus, we replace y, yani we remove y, and we write instead of y, negative 2. So let me explain it here. So it is 10 minus y. So what I need to do here is to remove y and to replace it by negative 2. Okay, as he said, y equal negative 2. So when you calculate here, it will be 10, and we know from before that negative is positive. So 10 plus 2, so it's equal to 12. Okay, negative multiplied by negative, it's positive. So 10 plus 2 equal 12. So this is what we made, or what we have done here. So I replaced y by negative 2, and now it is like this. Okay, so this is y, negative 2, so it's 10 plus 2, it's 12. Done? Okay, the next one, 2x plus 5 for x equal 3. So what you need to do here is to remove this x, and write bracket 3. So when you want to replace or to substitute, okay, you need to replace x by the number and with brackets. So replace x by 3, so it will be 2 bracket 3 plus 5. Okay, so it's equal 2 times 3 is 6. This is 3, and this is for y, or x. 2 times 3 is 6, plus 5 is equal 11. So that's it. Only replace. Yeah, the next one, more advanced. Okay, it is x squared minus 3y minus 4. For x equal negative 1 and y equal 2. So what you need to do here, you need to replace x by negative 1 and y by 2 only. Okay, so x by negative 1 and y by 2. Let me remove all this and solve it manually. I think it's better. Okay, so look, what should you do here? So you need to replace x by negative 1. So I should remove x and write negative 1 squared. Okay, minus 3. I should remove y here and write 2. 3y, so 3 times 2 minus 4. I think it's clear now. Why? It was like this. It was x squared minus 3y minus 4. So I replaced x by negative 1 and I replaced y by 2. Okay? Okay. So now complete. So complete solving, I mean. So it's equal negative 1 squared, negative 1, all of it squared. So it would be 1 minus 3 times 2, it's minus 6, minus 4. So the answer is 1 minus 6 minus 4, so it's minus 9. You could calculate it mentally or using your calculator here. So 1 minus 6 minus 4 is minus 9. Okay, but I prefer in this stage to solve it mentally. It's better. Okay, The next one, minus 2x cubed y squared z t squared, all this for x equal negative 2, y equal 3, z equal 5, and t equal minus 1. So I will color x by blue, and I color y by yellow. Okay, so you need to replace also z by 5, and with purple t by minus 1. So look what should we do here? Minus 2 x cubed. So minus 2 cubed. I replaced x, the blue one, by negative 2. Then y by 3. Then z by 5. Z with no exponent. Then t squared. يعني minus 1 squared. Okay, and calculate all those together. You'll get minus 2 times minus 8. Why? Since minus 2 cubed is minus 8. 3 squared is 9. 5. 1. So it's equal 720. You could use your calculator to get the answer 720 here. Okay. The next one, multiply two terms or monomials together. So to multiply two terms or monomials, steps, okay, sine times sine. So let's check these examples to understand more. 3x squared times 7x power 4. So first we should multiply 3 by 7 to get 21, and then we multiply the x squared, variable x squared, times the variable x. Here we have same variable. We know when we have same variable, so we add the power. So 2 plus 4 is 6, and we copy x. So we copy x and we add the power. Okay, so it is x power 6. Second one, x squared y cubed z times negative 3 x cubed y z power 4. Okay, so let's start by the coefficient. What's the coefficient of all this term? It's only 1. When there is nothing before the term, all this term, so we say that it's only 1. So we never write 1x squared y cubed z. We write only x squared y cubed z. So 1 times negative 3, it's negative 3, so it's finished. Let's start by x squared. X squared times x cubed. So it will be x power 5. We add the power. We copy the base, we add the power. Okay. Y cubed. Okay, y cubed times y cubed times y. What's the exponent of y? I suppose that you would answer the exponent of y is 1, since we said this. So y cubed times y, the exponent here is 1. Okay, so let me write 1 just in order not to confuse, and we add 3 plus 1, it's 4. So it's y power 4. Done. The last one, z, the exponent of z, it's 1. And z power 4. So z times z power 4. So it will be z power 5. Okay, and finished. Check this. Minus 2ab cubed c squared times negative 5ab power 4. First, we write negative 2 times negative 5, so it's 10. Negative times negative positive, 2 times 5, it's 10. The second one, a times a. A times a, so a power 1 and a power 1 here. So a times a is a squared. We add 1 plus 1, 2. The exponent is 2. B cubed, b power 3 times b power 4. So same base, bb. Power 3 here and power 4. So we add, so it will be b power 7. Okay. And the last one, c squared here. But there is no c squared in this term. So we copy it, c squared. That's it. Let's go to the next one. Addition and subtraction. How to add two terms together. Okay, so steps. Okay, steps to add monomials is to add or subtract their coefficients. Okay, and keep the variable and keep its exponents as it is. Okay, but in which way? One, we have only like terms, only the like terms. And to take example about here, 3x plus 5x. What's the variable here? X. What's the variable here? Also x. So 3x plus 5x, it is 8x. Okay, 8x. That they are like terms. The second one here, 5x minus 8y. Y is a different term. It's unlike term. So here we have unlike term. So it's impossible. We keep it as it is, as we said here. We keep it like this. 5x minus 8y. They are unlike terms. 7y minus 3y. So 7y, 3y. Y. We have like terms. So we add or subtract the coefficients. 7 minus 3, it is 4. Okay, 4. And we keep y. We just write y. Okay, but minus 2x cubed minus x cubed. X cubed and x cubed. So we have like terms. So we add the coefficients. What are the coefficients here? In here we have a coefficient minus 2, and in here we have a coefficient minus 1. So minus 2 minus 1, minus 2 minus 1, minus 3. Okay, and we write x cubed, and here it is. Okay, yeah. Go to the next one. 2x cubed y plus 5xy. They are unlike terms. It's clear that they are unlike terms. Here we have x cubed, here we have x. Minus 4x squared y cubed z plus 4x squared y cubed z. Okay, so let's check if they are like terms. X squared and x squared. Y cubed, z, z. So they have the same variables, same exponents, so they are like terms. Okay, fine. So what's the coefficient here? It's minus 4. What's the coefficient here? It is plus 4. So minus 4 plus 4, it is 0. So the answer here it's 0. Okay, so when the answer is 0, we never copy this, and we never write 0 x squared y cubed z. Okay, we just write equal 0. Okay, let's go to the next one. We still have 3 slides only, or 4. Reducing like terms. It's the same. Okay, it's the same. If in an algebraic expression, we have many terms, monomials, and we wanted to reduce this algebraic expression. Steps: collect like terms or similar monomials, add or subtract these like terms. It's the same idea, but just more advanced. For example, here, look at this example. Let me just remove this. Okay, just to make it clear, it's better. 3x squared minus 4x power 5 plus x power 3 minus 4 plus 6x power 5 minus 5x squared plus 2x plus 4x cubed plus 7. What should we do here? We need to reduce, and it means to collect the like terms. So we usually start, by this. Let's check 3x squared. We have 3x squared here. X power 5, no. X power 3, no. 5x squared, so this and this are like terms. X cubed, 7, no. So these two are like terms. So 3x squared minus 5x. 3 minus 5, negative 2. So we write negative 2x squared. This is the I. minus 4x power 5. Let's check if there's any x power 5 here. X cubed 4x, 6x power 5. X power 5, no. So let's add minus 4x power 5 plus 6x power 5. Minus 4 plus 6, it is 2, positive 2. So it is 2x power 5. Okay, here we go to the next. X cubed. Are any x cubed here? Yes, there's 4x cubed. So x cubed plus 4x cubed. What's the coefficient here? It's 1. What's the coefficient here? It's 4. Yeah, plus 1 I mean here, and plus 4. Plus 1 plus 4 plus 5. So we write 5x cubed. That's it. Go to the next. Minus 4. And here we have 2x, and here we have 7. So look at the 2x here. Is there any other variable containing x? No, so we copy it. Okay, and the last one, it is minus 4 plus 7. Minus 4 plus 7, no variables, so only numbers, so we add them. Minus 4 plus 7, it is 3. So this is the final answer. Minus 2x squared plus 2x power 5 plus 5x cubed plus 2x plus 3. Done? Okay. Let's go to the next. Addition and subtraction of algebraic expression. Also, we are in the same idea, but in this part we will have, if we have two algebraic expressions, how could we add them? Let's take an example. Look at A. This is A. A equal, A is an algebraic expression, okay, capital A. Equal 2xy minus 4x squared plus 5x squared y minus 3. And B equal 6x squared minus 5x squared y minus 1. Okay? But how could we add? If we have A, look at this, A plus B, A plus B. So how could we write? We add A and B. And it means we add all the terms here with all the terms here by collecting the like terms. Okay? So this is A. A is 2xy minus 4x squared plus 5x squared y minus 3. This is A. Okay? And B. Well, since we are adding here, so we just copy this with the same sign. So it is plus 6x squared minus 5x squared y minus 1. This is A and this is B. Let's now collect the like terms. Okay? Let's collect the like terms. So let's check 2xy. This 2xy. Okay, let me remove this. Some things here. Okay, 2xy. Look at 2xy here. Is there any other 2xy with this terms? No, so we copy it. Okay. Minus 4x squared. I just scratched like this. Minus 4x squared. Is there any other variable with x squared? Here we have x squared y, so it's not. Minus 3 plus 6x squared. Yes, we have x squared. Okay, so minus 4x squared plus 6x squared. Minus 4 plus 6, 2. 2x squared. So this is it. Here, it's 2x squared. That's it. What do we have else? We have minus 5x squared y. And here we have minus 5x squared y. So this cancelled with this. Why? Since 5 minus 5 is 0. So we never write 0. Okay? So we still have minus 3 minus 1. It's minus 4. So we copy it here. This is minus 1. Minus 3. So it's minus 4. And we copy it here. Okay? So it's just like this. Check it again if you want. I erase all those. Okay? So only we have this cancelled with this. and 2xy, we copied it here since there is nothing else, and we have minus 4x squared y with 6x squared y, so it is 2x squared y, and we have the last one minus 3 minus 1, so it's minus 4. That's it. Okay, subtraction of algebraic expression. Okay, same idea, but if we want to subtract, so look what's the difference. We have same a as above, this is a, and same expression b, which is this, the same. But what if we are subtracting? If we are subtracting a and b, okay, so what will happen? So look at this. When we are subtracting, first we should write each into brackets. Look at the difference here. We didn't write brackets. We just copied them directly. Since the plus sign here never affect this one. But here, when we are subtracting, we should write brackets and a inside it, minus brackets and b inside it. This is b. We copy, just copy. Okay, fine. What will happen after this? After this, we need to remove the brackets. So when we remove the brackets from A only, here till A, nothing changed, but the negative sign that's here, will affect all the terms inside the brackets. So we are multiplying negative by 6x squared, so it will be, look, negative 6x squared. My negative times negative 5x squared y, so it will be positive x squared y, and plus 1, negative times negative, positive. After this, we should collect the like terms. Do the same way. So 2xy, we copy it here, 2xy, minus 4x squared, minus 6x squared, so it's minus 10x squared. So you'll feel at the beginning that it's hard, but really it's very, very, very simple. Minus 6x squared, 5x squared y with 5x squared y, so it's 10x squared y. Got the difference? It's 10x squared y. And 5 plus 5, it's 10, so 10x squared y, right? Okay. Minus 3 plus 1, minus 2, done. That's it, finished. 2a minus 3b, it's the same idea. So 2a, this is a, and this is b. Okay, so 2 into brackets, 2 brackets, a minus 3 brackets, we copy b. Okay, and now we remove the brackets. So when we remove the brackets, look what will happen. 2 times 2xy, 4xy. 2 times 4, 8x squared. 2 times 5, 10. So we copy. 2 times 3, 6, negative 6. Now, negative 3 times 6, negative 18. Okay? X squared. Negative 3 times negative 5, it's positive 15x squared y. Negative 3 times negative 1, it's positive 3. And now we collect the like terms all together. What are the like terms here? For xy, there is nothing xy here. Check them. So we just write 4xy minus 8x squared. Anything else with minus 8x squared? Yes, there is 18 minus 18x squared. So minus 8 minus 18, it's minus 26x squared. That's it. 10x squared y plus 15x squared y, so it's 25x squared y. Okay, minus 6 plus 3 minus 3, and it's done. That's it. Okay, anything here is a practice. Okay, so let's practice quickly. This may be the video is long today, but it's a very, very important and lesson. Okay, 3x power 5. Reduce the like terms. The question is 3x power 5 with 2x power 5. So 3x power 5 plus 2x power 5, it's 5x power 5. Next, minus 8y power 4 y power 4 we search. Okay, that's it. Plus 3, so it is minus 8 plus 3, it's minus 5, so minus 5 y power 4. Okay, next 6a squared b, a squared b, this is a squared b, so 6a squared b minus 2, 6 minus 2, 4, so 4a squared b. And at the end, finally, we have some minus 7 plus 6, so it's minus 1. That's it. Okay, let's go again. X squared y. Is there any other x squared y? Yes, that's it. X squared y. Else, no. So add x squared y minus 3x squared y. What's the coefficient here? The coefficient here is 1, and the coefficient here is minus 3. So we add 1 minus 3 is minus it's minus 3 here, yes. Okay, and here we have 1, so 1 minus 3 is negative 2. Okay, so here it's negative 2, so by mistake it's written negative, so it's negative 2 x squared y. Okay, so that's it, negative 2 x squared y. Again, negative 3y squared. Okay, negative 3y squared with 1.5 y squared. There is no L, nothing else. So negative 3 plus 1.5, it's negative 1.5 y squared. That's it. Okay, so again, 5y cubed x squared with negative 0.2 y cubed x squared. So just use calculator. 5 minus 0.2 is 4.8 here. And finally, we have minus 4. Okay, there is nothing here with a number, so minus 4 it's alone. Okay, so we copy it here, minus 4 only. Okay, so but just copy minus 4 only. Let me write it forgot, I think, to write it here, so it's minus 4. Done? Okay, go to the next one. The next one here we have 4a squared bc cubed. Is there any other one with a squared bc cubed? This one. Anything else? No. So it's 9a squared bc cubed. Okay? Yeah, the next. Minus 8t. Here 4at. Here 10t. So minus 8 plus 10, it's 2t. Very good. Go to the next. What do we have else? Minus 4at plus 2at. So it is negative 2at. And minus 5y, we copy it here at the end. Okay? Yeah, the next one. It's here with fractions, more advanced a little bit. Okay, so this you solved them before with Ms. Carla last year. 1 over 3x squared. Is there any other x squared here? Let's check. Yes, it's 2 over 3x squared. So 1 over 3 plus 2 over 3, so it will be 1. So 1x squared. Done? 3 over 5x minus 1 over 3x. There anything with x? Yes, minus 1 over 15x plus 4 over 3x. All of them. Look, 4 like terms. So it's it could be 5 like terms or 10 like terms in the same expression. It's not necessarily to be only 2 like terms like here and here and here. Okay? So we add all together, we get 23 over 15. And the last one, 22 over 9 plus 29 and 7 over 29, so it's 1. So we copy it, so it's 1. Okay? Only, that's it. Calculate the numerical value, the last question of each of the following algebraic expressions. Maybe you get tired from this lesson. I know it includes a lot of powers and you need to compare, but believe me, it's very, very easy. Anyway, we will complete, and we will complete this lesson grade 8, and we will take more advanced. I will repeat some ideas with more advanced questions, so you'll feel that it was very easy. 3a cubed for a equal negative 2. What should we do here? We just replace a by negative 2. So 3 into negative 2 cubed. So 3 into negative 8, so it's negative 24. Okay, yeah. ab squared 4. A equal negative 3 and b equal 1. So we replace a by negative 3 and b by 1. That's it. So this is a, the blue one, negative 3, b squared, so 1 squared, to compare this with this here. So negative 3 times 1 is negative 3, that's it. For the last one, x squared y cubed for x equal 2 and y equal 1. Okay, so negative 3x squared y cubed with x2 and y1, so it will be negative 3 into 2 squared y cubed 1 cubed. So just calculate. So negative 3, 2 squared is 4, and 1 squared is 1, so it's equal minus 12. Just multiply. Last one, minus 4x squared yz cubed. For x equal half, y equal 1 over 3, and z equal negative 3. So also here just replace and substitute x by this is x, and y, the yellow one, by 1 over 3, okay, and z by the green color here, negative 3, negative 3. That's it. Just compare and calculate here. You'll get the final answer, negative 9. This is everything for today. I hope you understood the lesson very well. Okay, I remember that all this you took them in grade 7 with Mrs. Carla before, and I'm repeating the lesson since we need it in grade 8. Okay, it's a basic lesson in grade 8. So till now, you are able to find the numerical value of an expression, multiply two terms on monomials, reduce like terms, reduce an algebraic expression, and at the end perform operations of algebraic expressions. That is everything. Thank you so much. And if you have any question, you may ask me in the Zoom live. Thank you and bye-bye.